Very good morning. Myself, Prabhaharan J, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, we are going to discuss about the topic is linear convolution, and from the unit 1, that is discrete Fourier transform. From the subject is digital signal processing. Yeah, let me discuss. Yeah. Linear convolution is a mathematical operation used in signal processing to combine two signals and determine how one signal modifies other signal. It is commonly used in linear time invariant systems to compute the output when given an input signal and an impulse response. Input signal which is represented by x of n and the impulse response represented by h of n. And the convolution is which means output of the filter, output of the convolution is represented by y of n, that is convolve the two sequence is nothing but the multiply the two sequence, that is which is expressed as y of n equal to x of n into h of n, which means summation index k equal to minus infinite to plus infinite x of k and h of n minus k. K is nothing but the index of the sequence. Okay, y of n equal to summation, which means add all the sequence, summation k equal to minus infinite to infinite into x of k and h of n minus k. That means the given value, that is time domain sequence, going to represent in the graphical representation in terms of index k. Here you can see a linear time invariant discrete time system where the system input is x of n and then output is y of n. Okay, there are four methods available in convolution, that is a linear convolution. That is first one is definition method and graphical method, tabulation method, multiplication method. Direct method in the sense multiply the input signal x of n with the shifted and flipped impulse response, which h of n, and sum the overlapping values and each step. And tabular representation, in the tabular representation arrange x of n and h of n in a tabular form, then perform element wise multiplication and sum diagonally. And then graphical representation, flip h of n around n equal to 0 to get h of minus n, which means folded version of the signal which is represented by h of minus n, which means h of n folded representation of h of n is h of minus n. Shifted h of minus n for different values of n. Multiply corresponding elements and sum them. Okay. Multiplication method we will explain later. Yeah, four steps involved for computing convolution sum. That is, first one is folding method, second one is shifting method, third is multiplication method, after that final step is summation. Okay, these are the four steps involved in convolve the two sequence. Okay, this is the graphical representation we will discuss later. And there is some properties available in the linear convolution. That is, there are three properties, that is commutative property, associative property, and another one is distributive property. Here you can see the commutative property is nothing but the y of n equal to x of n convolved with h of n, which is equal to h of n convolved with x of n. Here you can see h of n is the system input is x of n, output is y of n, and x of n system input is h of n and y of n, output is y of n. Next one is associative property. Associative property, x of n into h1 of n multiple with h2 of n. The result of x of n convolved with h1 of n is again convolved with h2 of n, which is equal to the x of n convolved with or multiple with the output of h1 of n and convolved with h2 of n. You can see the diagonal representation here. Okay. And distributive property, which means x1 of n multiple with or convolved with h1 of n, this output added with x1 of n convolved with h2 of n, whole output which is equal to the x1 of n convolved with h1 of n plus h2 of n. Okay. And this is the graphical representation of the signal. Input signal x of n graphical represented by x of k in terms of k. H of k is h of n graphical representation in terms of k index. Okay, h of minus k is nothing but the folded version of the h of k, and h of 1 minus k is nothing but the shifted one unit from the h of minus k. We can get the h of 1 minus k. Okay, this is the 2 minus k. Okay. This is the multiplication method. They give two sequence. The given sequence is x of n and h of n. The length of the x of n is 5 and length of the h of n is 3. Each and every sequence of h of n multiple with all sequence of x of n. Here you can see the three sequence. Each sequence multiple with all 5 sequence of x of n. And this is the procedure for multiplication method. Here you can see likewise we can get the finally we can get the y of n equal to 6, 19, 40, 61, 82, 67, 40 for the given value. And tabulation method like this arrangement, arrange x of n and h of n in a tabular form, perform element wise multiplication and sum the sequence diagonally. And you can write y of n equal 6, 19, 40, 61, 82, 67, 40. This is the tabulation method. And definition method, you can solve the y of 0, y of 1, y of 3 up to y of 6 by using the convolution sum, which means linear convolution formula. Here number of iteration level is 0 to n minus 1, which means small n equal to 0, small n equal to 1, small n equal to 3, up to whatever capital N minus 1 length. and finally we get the y of n equal to y of 0, y of 1, y of 2, y of 3, y of 4, y of 5, y of 6. Y of n equal to 6, 19, 40, 61, 82, 67, 40. And here you can this is the assessment of this video, which means this lecture. Define note this assessment. Define convolution sum. Total number of samples in y of n will be listed. List the methods involved to compute convolution sum. Y of n equal to h of n convolve with x of n, and h of n which is equal to x of n convolve with h of n. This is which type of which property of the linear convolution, and mention the linear convolution steps. What are the steps involved? Note this assignment and comment me the answer. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.